So hello everyone, good morning. I'm Amir and I'm the CEO and co-founder of UVeye, and we talk and we heard about this morning a lot about revolutions in the automotive industry, big data, and I want to show you how we can utilize the data also with some hardware that we develop in order to really change the market. We all see new advancements in the automotive market. We all hear about car sharing, carpooling, autonomous vehicles, but they bring new challenges. Today, on average, people use their vehicle 5% of the time. What should we expect when we use the vehicle 50, 60, or 70% of the time? What kind of maintenance issues would we have? Does it affect the safety of the vehicle? So this is what exactly we want to tackle. We want to understand the vehicles by its exterior. We want to do it fast and we want to do it accurate. Our story is a bit different. It started 14 years ago when I had a meeting in one of the governmental offices in Israel. Back then I was a soldier, so when I tried to enter the parking lot, the security guard simply did something like this. Try to see if I have anything underneath the car. 4 years ago, I had another meeting, and the security guard simply done the same thing. And you understand that nothing changed in the past 15 years. And when I asked the security guard whether he could see something, he said no. But if something happens while you're inside, they will look on the cameras and see that I try to do my job. So you understand something is not working here. So it took us 2.5 years to be able to build something that can really detect anomalies in the undercarriage. No one thought we could do it because basically the challenge is really hard. And let me show you why. So if you take this example, this is how an undercarriage of a private vehicle looks like. And I would tell you that there are some anomalies here. Would you be able to detect any of them? Anyone want to try? At least one? Nothing?
The catalyst sock is not aligned correctly.
Okay, so there are 5 anomalies in that specific undercarriage. Some of them are easier to find because they're not in the same color of the undercarriage, but some are really hard to find. And the challenge was how we can find something we don't know how it's supposed to look like. It can be in any shape, any color, any size. And adding to that, you have a lot of different types of vehicles, right? You have SUVs, private cars, full trailer trucks. So how do you solve it? But not only we can, so basically we rented every possible car in Israel to test our algorithms, but at one specific vehicle, we not only detected threats that are anomalies that are threats, but also we were able to detect an oil leakage. So we understood that we can understand a lot more about the vehicles and not only threats. So when we tweaked or changed the algorithm a bit, we saw that we can also understand and detect cracks, dents, rust on the chassis, but it wasn't enough for us. So we wanted to see what else we can do with the data. So we added 2 more poles that includes high-resolution cameras and audio sensors, and basically after a lot of collecting information and data, basically we can understand everything about the vehicle in a matter of seconds. We can see or detect everything from a small scratch or dent to problems with the brakes, suspension system, engine, exhaust pipe, everything, okay? So now let's talk a little bit about the magic and how we do it. So I said that we generate 3D models. The 3D models are actually helps us or give our machine learning a better way to, or an additional layer of information to be able to understand what we see. So if we take this example, I know it's a bit hard to see, and I give you the same example of the anomaly in the undercarriage, you can see it's really hard to understand and see it if you only use the color image. But if we use the 3D models that we build, we have the depth map, it's easier to see the anomalies. So we had to provide the machine learning more information. We said it's all about the data, but it's also what you do with the data, how you collect the data, what kind of sensor you use in order to bring more valuable data to the algorithm. A lot of time we hear that it's hard to use 3D models because they weigh too much, the size is too big, but also we saw that we can use low resolution images and 3D models in order to find what we need. But it's not enough. We wanted also to be able to detect not only what we see, but also what we hear. So if you combine microphone arrays in the poles and in the undercarriage, basically you're able to differentiate and isolate every part that you have in the vehicle. You can hear only the brakes, only the engine, only the suspension system, basically every part that you have in the vehicle. And some would say, but the engine contains a lot of parts. So you can only hear the water pump, the timing belt, basically every part. And then you can find for anomalies. But still we wanted to really understand the whole vehicle. So we added another module that only inspects tire. So we created a semantic segmentation to differentiate between the rim and the tire so we can understand and see if there's any damages. But also, you can measure the air pressure. You can read all the text on the tire, the size, the manufacturer, basically all the text that is written on the wall. There are a lot of different use cases to what we do. From being able to inspect the vehicle at the end of the manufacturing line or in dealerships during the PDIs, you can basically see everything from a 2mm dent to used cars. This is my first time that I visit SEMA. I saw a lot of classic cars, which are really amazing here. And think how simple it will be if you could simply drive through a system and you get a full report about the status of the vehicle. How it will shorten the time when you arrive to the dealership, to the garage, and by the time that you get to the receptionist, you get a full report with everything that is not okay with the car. Think about car rentals. I rented a vehicle when I arrived to Vegas, and they asked me to mark everything, all the dents and scratches that I have in the car. Basically, I tried to mark the whole vehicle so they won't tell me to pay for something I didn't do. But you understand that something needs to be changed. And this is exactly what we're trying to change. And this is, we talked about revolutions. We already see revolutions in the car industry, in the automotive industry. Thank you very much. Appreciate the time.